Now let's look at the next example, LeetCode problem called the task scheduler. So we are given a array of tasks and they are represented as characters. So in fact, uppercase characters. So there are at most 26 different tasks, but each of them may appear multiple times. And we need to schedule them on the CPU. So the task can be scheduled in any order, so there's no deadline or anything. And every 1 unit of time, we can run one task, and CPU can also stay idle. So I guess we still don't have a multi-core CPU yet for this problem. So the only constraint that makes the problem non-trivial is there's a requirement that the same task cannot be run too close together. So if we have two tasks A, there has to be n units time between them. And the question asks what is the least number of unit time so that the CPU will need to finish all the given tasks. So make sure you understand the problem description. And now we're going to look at the two samples. So let's look at the first one. So we have AAA, BBB, CC, D, and N is 3. So this is one way to schedule it. So we have A followed by B, by C, by D, and then we have A again. So we need the 3 in between two A's. So it's okay to have A here, and it's again okay to have B here, C here. But then the next one, the CPU has to be idle because we cannot schedule either A or B here, and A or B are the only ones that are left. So we need to idle, and then after that, we can schedule A and then B. So it takes 10 units of time. And if N is 4, then we need to take 2 more unit time. So we schedule like A, B, C, D. And because N is 4, we need to have an idle even here. And then we have, after this, we can have ABC, and then 2 idle, and then we can schedule AB. So I want you to think about how you would solve this problem. So the key constraint is that there has to be a gap of n between 2 consecutive tasks. So if we are asked to actually come up with a schedule, we can use a greedy approach. So which task we should schedule first? I think it's pretty obvious that we want to schedule the one that occur the most times because they need the most, we are basically constrained by them. So every pair of them has to be a gap of n between them. And after scheduling the first, every time if we need to decide the next task, there will be some tasks that are eligible, meaning that the previous instance of that task appeared at least n time ago. So now we can schedule it. So among all the eligible ones, we will want to choose the task that still need to occur the most times. So we can certainly implement this. It's fine. So I think the code is non-trivial, but it's still there shouldn't be any fundamental difficulties. Well, actually, I guess yeah. Well, since there are only 26 tasks, actually, you don't have to use fancier data structure like priority queue or order set. You can, every time you need to choose, you can just iterate through them. Yeah, so I think that's actually probably easier to code. However, for this problem, we don't actually have to come up with a schedule. The question only asks us the maximum number of time. So sometimes for this kind of a problem, you can actually figure out a formula for computing it without actually doing the scheduling. So we should pay attention to the task that appear the most frequently. So let's say the most frequent one appear F times. And also it's important how many such tasks appear F times. So let's say there are K of them. So for example, in this example, we have the F would be 3, K would be 2. So we have two tasks that each appear 3 times, and that's the most frequent time. So then what we can schedule is we have to accommodate this. And the hope is that once we accommodate all these tasks, then the rest should be fairly straightforward. So the way to accommodate this is to make a block of size, I guess this should be size n+1. So for example, here our scheduling can be viewed as we are creating a block of size 4. And then inside the block, we will put all the frequent ones. So we will put the A, B here. So we will create a block of size 4 and fill AB here, and then another block of 4 AB here, and then another block of AB here. And after that, we will just the rest of them will just fill them in. So C, we will put C in 1 in each block, and we will put D in 1 in each block. If the blocks are already full, then that when we try to put some, so for example, if we also have E, F, G, then they can be put here, and then the rest of them can be added to the end. So then that means the maximum time is simply determined by the total length. So the maximum time will be either determined by the total length, or it will be determined by these scheduling constraint that make sure the most frequent one are adequately handled. So, and that number is yeah, so I think this formula might be, it should be n+1. Let me look at the code. Yeah, it's n+1, yes. So we first need f-1 blocks, each of them of size n+1. So like here, we need, because they appear 3 times, we need 2 blocks, each of them of size 4. And after these blocks, these ones still need to appear at least once. So the formula is f-1 times n+1 plus k. So there are k items that appear most frequently. So essentially the answer will be the max of this and the size. And it turns out that this is correct. So this heuristic is correct. So this is a code for doing that. Just scanning through the array, keeping track of the maximum frequency and the number of characters that have the maximum frequency. So once we have that, we will just return the max of this these 2 values. So I think the reason why this is correct is actually not totally. It's not totally obvious. So the what I just described is actually not a foolproof. The foolproof will be a little bit more tedious, even though intuitively it feels correct and it turns out to be correct.